Dear students, we are going to discuss a topic called vectors. Vectors, nowadays it is very well used in the GPS system. What is GPS system? Global Positioning System is a system to design to help the navigate on earth, water and in the earth. So, vectors is very well used in GPS system nowadays. So called the drivers are using the GPS system to find out the place where we are supposed to go. The same vectors we have discussed in various levels and we have used in properties too. That properties are so many things we have discussed and so many things we have come across. But now in vectors algebra, you may know many fundamentals of how to add two vectors, how to distinguish two vectors, how to differentiate vectors, all those things you know. But now this topic, this particular exercise 8.1 discuss a problem called position vectors of two A and B. See the problem here. Let A vector and B vector be the position vectors of the point A and B. Prove that the position vectors of the points which trisects. Trisects means it divides. It divides the segment AB are two different results, which is A vector plus 2B vector by 3 and B vector plus 2A vector by 3. These two results we are going to prove, for which we should know certain basics. What basics that we want to know is a line segment which divide internally. This is the very fundamental rule that I am going to apply. So, if A and B are any two vectors, let P be the point which divides the line segment. So called vector is a directed line segment. Directed line segment is direction as well the magnitude. So here very important cases we are going to see the direction as well the magnitude. So the line segment alone is a scalar quantity and vector is a direction as well magnitude, and it is the ratio m is to n. R vector is equal to mb vector plus na vector by m plus n. It is how to remember. It is very simple way. There are two vectors A and B and it divides this point R as m is to n internally. That word is very important, internally. So that means m into B, n into A. Just you can reciprocate. So you take the values in other way. It is m and B, n and A. Like this you take. Simple way to recall mb vector plus na vector by m plus n. The same approach I am going to apply here. So now let us think about this. Here first point is A vector plus 2B vector by 3. Here let me take the point here. I just going to draw a point here. Now this is O, A and B, that is we take a point A and B as a line segment here. This is a line segment, and O to A, the position vectors of point O to A, the position vector of point O to B is a B vector. It divides this line segment 2:1, 2:1 ratio. So here case 1, let me take case 1 here. Let O be the point. Let O be the position vector of the point. Position vector of a point P, O here. Let O be the position vector of the point. This is a very important point, O to A, O to B. We are going to represent a vector now. So let us take OA vector is A vector and OB vector is B vector. What I have taken the point here is R. this R divides this line segment as 2:1 internally. Here what we represented m is to n. Likewise, I am taking 2 and 1 in the place of m and n. So just mere application of this formula, that is R vector is equal to mb vector plus na vector by m plus n. So here let me take that, let P be the point. P means always we used to represent a point is P here, this point, that is R. Let P be the point which divides A and B internally in the ratio m is to n. In the place of m is to n, here it is 2 and 1, m is to n as 2:1 here. As you know very well, what the formula for the line segment for internally mb plus na, I am just same thing, I am going to take R vector is equal to, so 2, as I told you, 2 into b, 1 into a, so 2 into b vector plus 1 into a vector by 2 plus 1, which means R vector is equal to 2b vector plus a vector by 3. That is the first result I have proved here, a vector plus 2b vector by 3, the first result. And the second case is, what is that? Case 2. Case 2, we wish to prove the second result is b vector plus 2a vector by 3, for which also we have, because the question is very clearly given, trisects. Trisects means it divides, it means in 3 points, like this way it divides. Actually trisects means just you take a line segment like this and it divides like this. But I have taken for a reference point of case 1 as well case 2. But actually it divides like this. This line segment trisects. So 1 and 2 and 3. 1, 2, 3. 3 ways it is trisects. It divides. But I have taken 2 cases. Case 1 as P is a point. Now let me take the same way this trisects, I will take in other way. So here the case 2. This is Q, the same A and B. Actually that point is located other way, that is O to A and O to B here. First case, P is the point, divides the line segment 2:1. Now the same thing 1:2 here. 1:2. So the 1:2, how it is divided now? The same formula, same approach. Let Q be the point, divides AB internally, the ratio (1:2). Instead of 2:1, we case the other way, that is 1:2. That means here also the case is m:(n) would be written like this way as 1:2 using same formula. Formula is simple, so simple formula, so it is nothing but section formula. So here OQ vector, in otherwise we can take it as R2. So this is, we shall take it as R1 as this one, if not we will take it as R2. The result is nothing but something like R2. So 1 into B vector plus 2 into A vector by 1 plus 2. That means B vector plus 2A vector by 3, that is R2 vector. in both cases we have applied section formula. One is P is the point which divide AB internally as 2:1 and we have proved the first result, and Q is the point which divides same AB in 1:2. That means this result has been proved. So, in both cases these two results are proved. That is, in what way it is trisects? The line is trisect, the line segment is trisect, divided in 3 parts as P as well Q. So, we have found out 2 important result, 2b vector plus a vector by 3 and another result b vector plus 2a vector by 3. With this problem is solved.